Alright, so we seem to be pretty much at about 8 p.m. EDT here. So welcome to tonight's Hydra workshop. I'm Andre J. Thank you for stopping by. Word. I mean, I think processing is actually more difficult than Hydra, to be honest. But yeah, if you're cool with the format of processing, then Hydra should be like pretty chill zones as well. It's just a little bit different of a signal flow kind of thing, I think. But yeah, so I'd like to try out a couple of different things for this workshop. First off, apologies to everybody from the last workshop thing that I tried to do on Wednesday who didn't get emails about it. That was my mistake. I was trying to use a different service for automating things, and they all got sent to your spam folders, so that's what's up with that. But also, people who did show up, there was a lot of issues with like people's systems crashing and everything, and people unable to like log on. So yeah, I'm going to try something different for this one, and then for the vSynth workshop this Wednesday in 2 days, and for the Video Waves workshop next week. I want to try doing them on Twitch because I feel like if I do them on Twitch, then you'll be able to see what I'm doing on my screen pretty well. And then try to have the discussion. If you scroll down on the Twitch page here, you'll see a little link to the Scanlines Rocket Chat zone. If you can hop over there and get into that chat room, you can like take like snapshots of your screen and share them. So if you want me to help out with like troubleshooting errors that you're having, or you're having trouble catching up, that might be a little better. Because I don't think that Twitch lets you add photos to the chat, but I will keep the Twitch chat happening through this as well, so I can respond to questions either way. But I guess for the most part, I have a couple of things prepared. I'm probably only going to do this for about an hour, though, because that is about as long as it takes for my throat to get sore if I am talking constantly. And there are two things I'm going to focus on this. So I'm going to be not just necessarily teaching Hydra, but I want to teach about modulation and feedback in general. I'm going to be teaching you how to use modulation and feedback in Hydra, but the same basic principles will work for any kind of video synthesis system. And I think that's when I try to learn systems and I try to like figure out how to like make my way around them, modulation and feedback are the two basic kind of things that I focus on all the time. But I'm going to start off with actually a bit of a digression into, I'm going to be using modulation, but I'm also going to like show you, this is just something fun I came up with while I was preparing for this, about how you can use sort of like optical illusion kind of things for more, for really dynamic effects. So I've got this thing set up right here, and let's just kind of, I think I can comment this whole thing out. Can I? Oh, I gotta keep the out happening. That's what's up. So I'm gonna work my way back up to this. Actually, I might just save this somewhere else. All right, so let's talk about modulation. And we'll start with just a shape. Okay, so we have a shape, and I am modulating the size of this shape using this function right here. If you're following along, simplest thing to do would just be grab this thing, cut and paste it into your zones, and don't worry too much about what this is actually meaning. The only things that you kind of really need to like think about in this little string here is we're using 0.5 here to change like the total size of how this is modulating, and then we're using time in here to change the speed of how things are modulating. So if I do like 0.25 times that, then we see it slows down the modulation. And if I multiply this by times 0.25, then it changes the amplitude of the modulation. So no matter what this looks like, what this is actually doing is this is just like curving oscillators. This is basically like, it's not a video oscillator, it's just a one-dimensional oscillator, so it's changing the total amplitude, the total size of this square as a function of time. So this is pretty interesting. Well, no, it's actually not that interesting on its own. This is pretty boring. This is like one of the first things you might learn how to do in processing. But it's theoretically interesting because we can use this with other things to do more interesting things. So let's see. Let me take another shape. So let me just cut and paste this chunk of code here. And I'm going to mix this together with the oscillator. So there's a couple of different arguments or functions for mixing in Hydra. For this one, I'm going to use diff. Diff means difference. This just means that you subtract the RGB values of one from the other. So since shape is by default just filled with white, if I difference this with another shape, then it'll be black. And if I just execute this line right here, what's going to happen is that doesn't like that because I kept that period in there, is that nothing happens because we're just taking one square and subtracting that exact same square from it. But if I go up here where there's 0.25 times math abs, and I go delete the 2, so it's just 0.5, we'll see what happens is that the second square is 1/2 of the size of the first square. So it's going to just zoom in and out like an outline right here. If I change the value of this one so it's a little bit bigger, like 0.45, then we have a thinner outline of everything. So that's pretty neat. We kind of have something slightly more dynamic going on here. But something which I would kind of like to do is, you notice how both squares are modulating at the exact same rate? I want them to modulate at different rates, and not just different rates, but I want them to be modulating in a sort of complex way. So if I do the same thing over here, where, here, let me put this back to 2.5. So if I take this one and just delete the 2 here, and then I re-execute, what's going on is that the first square is going to modulate twice as fast as the second square. Because this is 0.5 and this is 0.25. So this means that they're now modulating at different rates, but what happens is that you're going to notice that it'll cycle. You'll notice that the pattern will kind of start from there where they both hit 0. And they start out like that. You can speed this up a little bit, and maybe you'll notice it better. Haha, one of them just stopped, didn't it? Oh no, it's still going. And then starts over. So I have a slightly more complex pattern of modulation happening, but it still has a pretty perceivable beginning and end. Like every time they both go back down to 0, we can see that's the start of things. But a really simple way I can change this so that they have a bit of a, so that the cycle doesn't repeat so quickly, is if instead of 0.5 and 0.25, you notice that these are 0.5 and 0.25. 0.5 is 2 times 0.25. So that means that when one peaks, that they're at a ratio of like 1 to 2 to each other. So if instead I change this to be like 0.49, and I change this to be 0.27, then if I speed it up a bit, then we're not going to be able to see them repeat for a very long time, because 0.49 and 0.27, 0.49 is almost 2 times 0.27, but not quite. They're gonna cycle. They're at a ratio of, instead of being 1 to 2, they're at a ratio of like 0.49 times 0.27 because they're co-prime. The takeaway from this is that if you want to have different sorts of things modulating together in more complex ways, then you want to just have these sort of like, kind of try to pick like sort of like random numbers that look prime to you, like 11 and 37. Do this. So like, it doesn't actually necessarily matter exactly what these two numbers are. You just kind of don't want them to be like simple multiples of one another, like 1 and 2 or 5 and 20. Just having more complex things happening with these will give you more dynamic kinds of modulations. Does that make sense at all? Am I just rambling on? Is this useful information for anybody? Well, now that we have that, I always forget there's like a 10-second delay, so if I ask a question of people, then I need to wait like 10 seconds for a response. But also, I don't know, asking questions of people when I'm doing like the live streaming thing just almost exclusively feels like I'm just like shouting into a void. It's kind of the reason I don't usually do too many classes like this. Oh, hey Bill, what's happening? But yeah, I figure this time I would try to do a different kind of class where I'm just going to kind of do it as a lecture, and then I'll save it and people can look at it later. And you have the option to communicate with me, but you probably won't, so I'll just kind of keep on rambling. So yeah, if you want to follow along and you just joined in, here, let me just copy this over. You go over to hydraojak.xyz, load that into your zones. You might need to do some kind of formatting thing with it. I don't know how Twitch chat handles this kind of thing. I see absolutely nobody has headed over to Scanlines to the workshops. Yeah, so I'm just going to basically amuse myself here at this point. So we can add like a nice little gradient thing to these squares. The gradient along the outline. So if I just do 0.2 here, and then add 0.3 here, then we get that really nifty kind of like gradient thing happening. And then I kind of want to show y'all this kind of fun optical illusion thing I came up with. I mean, I did not invent optical illusions. I just stumbled across this while I was playing around. But using optical illusions and sort of like using like perceptual tricks in video synthesis is pretty crucial. If you can see, sort of, we're using one right now, which is sort of parallax. Like we have these two squares pulsing in and out of one another. That's totally two-dimensional, but we definitely feel as though there's like an element of depth happening, like I'm zooming in and zooming out and pulsing in and out of this sort of cave. And we're also using the fact that they're modulating at co-prime arguments to sort of feel like, instead of just pulsing in and out in like a really repetitive rhythmic manner, it's shifting and morphing all the time. And then I'm going to add one more thing that will add another level of all of this. So if I just put an oscillator here, let me put the oscillator at just a frequency of 1, slow it down a little bit, and let's execute this. So check that out. Right away you'll notice that, so these squares were perfectly level. They're perfectly equal and they were like parallel with one another. But as the background shifts in a gradient manner, we get this sense of shifting where like we're sort of like moving like askew back and forth. So that's basically has to do with how humans perceive brightness. Is we don't just perceive brightness as like a scale from 0 to 1. That's how we like program brightness pretty much usually, is just like a linear thing. But we actually perceive brightness with like, we perceive brightness in context. So if we change the context of the brightness of this thing, it makes the whole everything kind of throb and ooze and morph in a different way. If I change the frequency of this oscillator, we go up to 10. Then we see we get this. And it's also partially because we're doing like the diff operation on each one of these two. But right away you can see that we've got like, we had a really simple thing that we started out with. We just had 2 squares pulsing in and out. But just by adding the sort of shifting gradient behind everything, then we get this kind of crazy extra effect, which is, it's mostly just happening in our perception. This modulation isn't exactly happening on the screen here. We're using our perception to kind of like change everything. And that's a really, really fun and interesting thing that you can do with video synthesis is, since video synthesis is based pretty much entirely on like manipulating a 2-dimensional image, and because human perception is based almost entirely on like taking 2-dimensional image information and then converting that into like more like 3-dimensional information, then we can use that to do some pretty neat things. And if I also go and grab this and add that into the offset argument over here, and let me make this 2, and let me change this so it's a completely different co-prime thing to all of these. So I bet 79 is prime, right? Yes. Now let me slow this down a little bit so we can sort of make out what's happening a little bit better. So the offset is offsetting the RGB values of this oscillator, which used to be just like a grayscale oscillator, and it's setting it at this rate. So now we have the oscillator, which is its own modulation source, running at 10 hertz, and then we have this, the color that's coming out of it, the phase offset, which is happening at a different co-prime rate to this rate, and we're getting this really fucking crazy, like, glowing thing happening. And this just started out from having 2 squares going back and forth. You can maybe see this a bit stronger. If I turn off this gradient effect on both of them, then you can really make out how much of how much optical illusion is happening. Just by doing the differencing twice on these things, we get a really crazy wobbly thing happening here. If I speed this one up a little bit. Yeah, so that's pretty awesome. So that's just some notes on modulation that I wanted to start off with. Does anybody have any questions on this? And otherwise, I am going to move on to feedback. I'm going to wait 10 seconds. Oh yeah, if anybody feels like donating for this class, if they feel like they can afford to... How can you change the shape? Oh, okay. So, shape has 3 arguments. If we just play with like a regular old shape, let me take... The first argument on this is the number of sides. So if I change this shape to 3 and this shape to 7, then we've got a triangle with a septagon in the middle. But yeah, this first argument of shape is how you make different shapes out of that. And then you can also deform the shapes in a bunch of different ways, which I will go into a little bit later when we get into feedback. But the basic way to like mess around with the shapes is just with this first argument right here. Word. But yeah, if there are no more questions, then I will hop on into some video feedback stuff. So if you know me at all, you know that I like to play with feedback systems. And Hydra offers a really unique set of tools for messing around with feedback. most video synthesis environments, or not most video synthesis environments, most video processing environments are not really well suited to video feedback for a couple of reasons we'll get into later. But I think there's a lot of really unique stuff you can do with this. This is just me kind of rambling on just to make sure nobody else has any questions. I have literally no idea how many people could possibly be watching this right now, but I'm going to assume it's at least 3. Alright, video feedback. So, sort of the model of how I'm going to do these classes, and if I keep doing the Hydra classes, I'll keep trying to go with this model. So sort of start out with something, and then go through how I built up with it. So let's just erase all of this right now, and then let's start with this, and let's see what happens. All right. So here is the simplest way to do video feedback. Actually, this isn't even the simplest way. Let me comment this line out. This is the simplest way to do video feedback in Hydra. Actually, not even. I can do it even simpler. Here's the simplest way to do video feedback in Hydra, but it's so simple that nothing happens. So the thing about digital feedback is that in digital feedback, usually what's happening is you're just swapping a memory address. So nothing is changing about the image at all. So you pretty much always have to do something to the image if you want to see cool feedback effects happening. So what we have up here is SRC00. And just to be more explicit about this, let me put an 00 down here as well. So Hydra has 4 output buffers, and you can use any one of those output buffers as a source. I'll go into a little bit more explicitly about what that means later, but for now, you see we've got out 00 and source R0. So that just literally means take the output, grab that as an input, and then take that as an output and use that as an input, and so on. But we're not doing anything to it, so it's not changing at all. So I would like to see some hue shifting because I like rainbows. So let me take this Colorama thing here, and then we'll start to see some hue shifting. And I have to use the bathroom, so I will be back in 1 second. Hello, I'm back. Okay, so we are doing some hue shifting here. The way we are doing hue shifting is Hydra has a function here called Colorama. And Colorama just offsets the hue by a value. We don't want to offset the hue by a large value because that'll make things go crazy in strobe. Let me show you what happens when we use larger values. That was just going up an order of 10, and that got pretty crazy pretty fast. And then you notice, even if I go back to the previous value, it doesn't go back to that smooth blending that was happening earlier. It just holds this static strobing thing because the static strobing was what was happening earlier. It's another thing about video feedback systems is they are non-linear. You can't just do one thing and then go back to the other thing and expect everything to happen the same way. You can't just interchange orders willy-nilly and expect everything to happen. Video feedback systems are decidedly non-linear. They are very chaotic. This is sort of what makes them really fun to play with, but it can be a difficult set of intuitions to grab. But yeah, so this Colorama thing, we saw it was doing something neat before, but now it's just like strobing vomit. That's not super interesting. I could try blending it, but the blending it just kind of like froze everything. At this point, pretty much the only thing I can really think of doing next is, so I'm changing the hue a slight bit, but nothing's really happening. So maybe I should try doing some sort of geometrical thing. So I'm going to grab this rotate, uncomment this, and then see, okay, so we're back at some feedback zones. And then if I change, you'll notice if I have the blend on and if I have the blend off, we have two kind of very different things happening here. Not very different, but different enough. Blend off, things are moving kind of fast and they're pretty grainy as well. If I turn the rotate up, let me go up an order of magnitude here, and we get some more spinning things happening. And then let me turn blend off. Oh, there we go. And it seems to speed things up, and it makes it a little grainier. You turn it back on, but the other thing that we can do with blend is I'm going to add a comma, and let's say 0.2 here. So this just adds a tiny bit of blending. So we can use the blend function when we're doing feedback as sort of like a filter. You notice if we're just blending it with the previous screen and we're not changing anything, like up here when we start with source and we offset the hue and we rotate things, that's changing things and that's adding nonlinear operations into the mix. But then at the end of everything, right before I go out and I just blend it with the previous screen, that's just like filtering. It's like smoothing everything over. It's saying, remember what we did last time? Let's kind of make this look a little bit more like that and a little bit less crazy like strobing noise. Another thing you'll notice, you can give blend negative values. And it'll look like crazy noise, but there's some pretty nifty things you can do. You can give it values like 4. And this isn't always going to do interesting stuff, but it's just always nice to sort of play with the values of whatever you can feed into the functions, because that's sort of how I like to learn how to do things. And I think a big part about what I'd like to do with this is teach you how I learn things, not teach you how Hydra works, because, I mean, I don't know everything about Hydra. I just know how to do, like, some fun stuff with it. But I think it's more interesting to, like, figure out approaches for learning things than to actually like teach the things themselves, if that makes sense. But yeah, some other things we can do with this. So Colorama, this is a hue shifting thing. We can try to do a little bit more chill zones with this if I add, instead of rotate, let me use scroll X. Scroll X is a function that just moves something around in the horizontal direction. So there we go. We are scrolling. And wow, this is really washed out right now. What happens if I turn this up a little bit? There we go. So I'm getting a little bit more hue shifting action happening here, and then it turns into noise. There's some more rainbow zones though. That's what I was looking for. And then if I turn this up a bit, I bet we'll get, let me turn this up to like 4, and we get some more slow, noisy rainbow zones happening. But yeah, so the two basic things that you want to do with feedback systems is do something to the color space and do something to the geometry space. By geometry, I just mean moving something X, Y, Z, or rotate. So there's another function in here that we have called scale. Scale is how you move things in the Z direction. Now, of course, there is no Z on the screen. This is happening implicitly, not explicitly. But luckily, we are humans, and we are really good at taking two-dimensional information and grabbing space out of it. So if I do scale and let's do 0.99, this already looks like it's zooming out. And you can see there's a lot of really fun, like, texely pixelization things happening in here, which is always really, like, a fun bonus to have. Are there any questions on what I've done so far? Or what I'm doing right now? So this Colorama function, feel free to interrupt me. I really don't have the patience to wait for 10 seconds during a live thing. And if you interrupt me in text, it actually doesn't count as an interruption, whatever. Yeah, nobody's over at the scan lines. I guess that wasn't going to work out. So Colorama is, I prefer to work in HSV, or hue saturation value, hue saturation brightness space, when I work in video feedback systems. But Hydra natively, most of the things in the color zones here work in RGB or RGBA. So we can actually use a different function called shift to try to play around with things. And let me just show you shift for a moment. So if I use, instead of Colorama, I use shift. I need to give it, I don't need to, but I should give it 3 arguments. And each of these 3 arguments is going to offset red, green, and blue in that order. So if I say, let's offset red by 0.01, let's offset green by negative 0.003, let's offset blue by a large number. Let's see what happens if we do something large. Wow. I didn't expect that. Maybe I need to do the scale thing off. There we go. It's making things real dang dark. I wonder if I should turn off this blend. There we go. So that's a bit more what happens if you, instead of hue shifting, you do RGB shifting, you did this kind of behavior. So hue shifting will make things into rainbow zones, and it'll look like unicorns are vomiting all over your screen. If you use shift, you get this more sort of like glitch feeling, because what's happening is like, so we're adding like 0.001 to the red every time, but then when red hits maximum, it's going to start over at 0 again. So if you shift in these sort of unequal amounts of RGB, you get this kind of like cyclic glitchy behavior. And if we turn these values up, then it's just going to like go harder and harder. And I am about to grab onto one more mode where I start to talk about using separate buffers and doing signal feedback between them. So now is a great chance to ask me any questions about this specific mode before I move on. And I will slowly drink from this jar of water for 10 seconds. All right, no questions. So I mentioned before, thank you. I mentioned before that Hydra has multiple buffers that you can use. So let's look at some stuff we can do with 2 buffers. RC is not defined. Probably SRC is what I meant. There we go. So you notice here what I'm doing is I've got this one line here that ends in out 0. And then I made a little like style thing happening here. And then I've got another chunk of code that ends in out 01. And then I have this new argument, render, at the bottom of everything. So what render is doing is it's rendering all 4 buffers. Except I only have 2 buffers being filled right now. But if I do something like shape for out 02, oh look, there's a shape over there. And if I do noise out 03, then we get some noise happening over here. So render with no argument is just going to show you all 4 buffers in a grid like this. But if instead I say, I just want to see what's happening in 0, then I can put that in there, and I've got 0. And if I want to go over to 03, then I just see that noise thing happening over here. But I kind of want to see them all right now. And let's ignore these two for the moment. So let's talk about, so I had some feedback happening in here. Let's not do feedback with this right now. So let's talk about signal feedback instead of video feedback. So what does signal feedback mean? So I've got an oscillator happening here, and let me take, so this one, we've got a triangle where the scale is modulating using an oscillator. So modulate scale. If you look over on the hydra list of functions page, there's this whole list of modulator functions. And these are all functions that modulate things, not like the thing I was doing before where I was using like time to make these one-dimensional modulations, but these are modulations that are based on 2 dimensions. So modulate scale oscillator, if I change the argument on this oscillator to 10, we see that it's literally like an oscillator like the one up here, which is modulating the scale, meaning modulating the zoom in and out of everything. But then there's something kind of nifty you can do with modulators when you have them in different buffers like this. So I've got this shape being modulated by an oscillator here, but instead of using that oscillator, I could instead use O0 as an oscillator. And look at that. So we've got, you can see very clearly that where this is white, it's modulating the scale a lot, and where it's dark, it's not modulating the scale at all. So the modulation, when you use a texture, a full like video texture like a square as a modulation source, it's grabbing the brightness values and using those as amplitude. And this is pretty much more or less like standard when you use like textures as a modulation. I guess I don't really know. I know vSynth uses it, and I know I've used it. I don't know what other things really have modulation sources like this, but if there's 3 people doing it in video synthesis design, then that's, you know, that's definitely a trend, right? But yeah, there's something else kind of nifty you can do. Say, I also want to modulate the scale of this oscillator. So I could use another oscillator to modulate the scale of this. I could also do a better job of typing things. So if I just put an os in here, so I'm just modulating the scale of this oscillator with another oscillator. And this kind of is working in a pretty similar way to like frequency modulation in a sort of way. You can kind of see, you can see it actually a little bit more clearly over here because it's like drawing like a wave shape like you would expect, as opposed to this sort of like the what do you call it? The perception grid. It's just there's a word for this kind of thing that's used a lot when you're like studying perception and human vision. I should have written it down. But another kind of crazy thing I can do is I can modulate the scale of this using O1. So this is what I mean by signal feedback. This is also a form of video feedback, but it's a little bit different. Video feedback is just done by taking an image and using like an iterative process where the output of that image is the output of the source is the input of the source. Whereas this is using this sort of like ping pong modulation feedback, and I differentiate this from signal feedback or from video feedback by calling it signal feedback, because this is a more abstracted version. It's not necessarily limited to just video, and you can use this in any sort of a dimensional zone. And this is fundamentally how chaotic systems, like if you want to explore chaotic systems, this is kind of how you do it. You take a system of iterative equations and use them in nonlinear ways in one another. So if we look at, put 0, 0, O0, and we can see the signal feedback is making these sort of like complex patterns along the edge here. And we can smooth them out a little bit. We can do a good old-fashioned blend O0. That'll smooth things out a bit. Kind of boring. Maybe we don't want to blend that much. That's kind of neat. But what if I don't want to modulate the scale of this one? What if I go down that list of functions and just try all the different modulates? So if we modulate scale with one output, and then I modulate repeat, what happens? Whoa, that's pretty nifty. Or what if I just do modulate? Ha 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 ha. Not too much happens there. What if I modulate? So you notice a lot of the times it'll be more sort of striking and dynamic when you use the same modulator in these sort of ping pong modulation feedback things, but not always. Woo. And you notice I went back and did that again, and that's doing something different than it was doing before. And what if I take a shape here? What if I shape, modulate? So nothing's modulating. You need to have something moving. The shape doesn't move on its own like an oscillator does. But we've got some other sources that move on their own. What if I use noise? Huh, nothing going on there. You know why? Because the modulate repeat is fractalizing things. It's not modulating things, it's just fractalizing. But if I do modulate scale here, then we can see on the inside here we've got these crazy little oozing bits here happening. That's pretty rad. And we modulate scale here. There we go. So that's happening a little bit more. Change the speed of this noise up a bit, then we'll see a bit more happening. So using noise as a modulator is kind of one of my favorite things to do in Hydra. Noise in this world, it's not like, when you think of noise, if you're coming from like audio processing, you think of like or whatever. But this kind of noise, this is called Perlin noise, aka smooth noise. And it's sort of a different sort of continuous feel than just like the random, the white noise of static. And you can use this as a really nice sort of non-deterministic feeling modulation source. Of course, since it is on a computer, it is 100% deterministic. It is modulating in a way which is complex enough in which you're not going to notice it so much, and it's not going to feel as obvious as, an oscillator. Where the oscillator, if you look at a video oscillator and you're not modulating anything inside of the oscillator, you've got all the information about what it's going to do forever in like less than a second. Whereas the noise, you can keep looking at it, and you can kind of see like there's a basic shape of things that's going to keep repeating, but it is never going to repeat exactly the same way. I mean, it probably will repeat exactly the same way if you wait long enough, because that's how probability works. But and then if we use noise to modulate noise, we get this really amazing texture happening over here. And then we can do some things to sort of combine these. Let's go over to, so let's grab SRC 0, and let's add some, here. Let's do something similar to what we were doing before. So, I'm going to grab Oscillator, and then 2.1, and let's just make this stable for now, and then let's diff with source S0 and go out O2. Okie dokie. Or did I goof up here? That's what I goofed up. So, my advice for troubleshooting in Hydra, there's only two things that you could ever possibly get wrong when you're doing Hydra, because it's so simple. All you have is these functions that you point, you add like periods and you connect them together. And the only things you really ever get wrong is you have a period in the wrong spot, and or you have the wrong number of parentheses. And everyone sort of has like different techniques of trying to figure it out. You're going to see what I'm doing here, where I try to make sure the period is on here, and if I'm nesting parentheses, I try to like give them some space so you can identify the parentheses better. But yeah, let's take a gander at this one a little bit more so we can see exactly what's going on here. We've got the signal feedback noise, and it's being diffed with this oscillator. That's pretty fun. And then if I grab this bit over here, and I modulate the oscillator a little more, there we go. So we're not quite getting that same sort of optical illusion happening here because this is too irregular. It's already looking like it's like, but with this sort of diff, the diff happening, it's looking like it's like thrusting out because the way that humans process sort of like figure and field. Oh yeah, for sure. Here, everybody who hasn't, who's having trouble keeping up, here's where I'm at. Oh yeah, and if you look over on the Hydra GitHub page, there's like some shortcuts for how to like auto format things too. I think if you like copy and paste code like this, there might be like some... Hydra works on Chrome-based browsers. I'm using this on Vivaldi right now. Vivaldi is basically built out of Chromium. But it'll work on Chrome. It'll work on, yeah. So, Bill, if you go, check out right up here where there's this question mark. And we'll scroll down here, and we go check out the documentation on GitHub. There is, it'll load up eventually. Control-Shift-F. Try Control-Shift-F to format the code. See if that helps out at all. But yeah, if you hit that little question mark up here, there's a complete list of functions. There's a bunch of user-generated sketches you can play with. There's tutorials and examples and everything. But yeah, Hydra is mainly for browsers. There is another way that you can run it on Atom if you don't want to use browsers for that. I haven't dug too much into that because you need to like format things for like Node.js and JavaScript things, and Hydra is literally the only JavaScript I will ever like willingly like write code in. So I haven't really like dug into that. But yeah, it's definitely it's browser and Atom based for now. I think there are there's like a Rust Hydra or something, or what's the other one? That one like Mac OS specific like shader code thing. It's not Rust, that's something else. But yeah, check out the Hydra. Can we export this with Spout? Yeah, you definitely can. If you have a way to screen grab with Spout, that is. I think actually, what do you call it? Not Spout, but NDI. You can use NDI and Spout together if you're on Windows to grab things off of the screen. NDI is a little bit wonky to dig into, but it'll be really, really useful for like this kind of a thing if you're trying to do like complex video synthesis things together. Yeah, but also, crap, I was just about to say something else about that, but, oh yeah, there's also, if you head on over to the Hydra GitHub page, you can see how to like sort of export, if you want to like just export the screen and not have the text all over it too, you can see information on that. Like, most of the questions you would be asking me, like most of the questions that people have asked me when I do these before are literally just the questions that are on like the Hydra GitHub page and the README. It's way easier to just like copy and paste the stuff over there than it is for me to explain these things. I can already feel that my voice is starting to hurt. So I might be wrapping this one up pretty quick. Now is a great time to have some more questions at me. So source works here. So in this case, you don't necessarily need to use source all of the time, I don't think. It's sort of a more explicit way to like say, but you do need to use source for certain things. So let me try to think of the best way to explain it. Source is kind of abstract because it's sort of like saying you're grabbing like a buffer from possibly something outside of Hydra as well. And while the output buffers are sort of inside of Hydra, they're sort of outside of it as well. So I'm using source as a more explicit way to like grab these. But also, if I wanted to grab something from a webcam, oh yeah, the other thing about source is, say I have source 0 here, or say I just had 0, I execute this and it runs fine. But then say I want to scroll X, it says 0 scroll X is not a function. But if I do src 0 scroll X, that is a function. So source sort of makes, it takes things and makes them into textures that Hydra can play with. The other way that you would use source is with cameras. So say if I have, let's call S0 init cam. Doesn't like that. Let me allow that anyway. And then let me add the camera in here too. So src S0. There we go. So I'm using, these are the only two ways I really use source. I use source for grabbing other buffers and feeding them into other buffer channels, or I use source to grab cameras and feed them into channels. So that's sort of my intuitive explanation of source. Does that help out at all? And it's a way to sort of use these things, because I could also, I could put S0 in here and it would still run fine, but I couldn't add any functions to it. I would have to add the source. So if I had to guess, I say it's converting something into like the texture that Hydra likes to play with. Word. And then almost out of time and my voice is almost gone, but did I connect the other camera? I should have another camera over here, right? I did connect it. Something else which is really fun, which you can do with this, is, so I've got an external USB camera as well, and I don't need to hit return there. So, it's my external USB camera, and once you have like a bunch of crazy modulation things happening, then it's pretty awesome just to try taking the camera, combining that with the modulations and pointing it at the screen. And right here, this is pretty fucking dank, yo. Yeah, feedback's pretty much what I'm all about. But yeah, you can also, so all of these things that I was talking about where I was using digital feedback, if you just grab a USB camera and plug them into there, you kind of save a lot of time because you don't need to have all of these other things happening. So if I have, yeah, most def. So if I just grab this source and S. Oh, let me put that 1 back in there. SRC S0 out. Huh. What did I do wrong this time? There we go. So you can see another thing. So this is sort of like a quirk about Hydra, but I think it's kind of nifty, is that unless you refresh the page, it's going to leave all the buffers there. So I erased all the buffers, but if I hit render, oh look, all those buffers are still there. But if I reload the page, then the buffers all disappear. Yeah, I can just grab the source. I can say it's invert. And then I can just do camera feedback jams. Or what else can I do? We can see what happens if I do shift. Oops, that does nothing. Maybe I need to do like shift 0.01. Huh, didn't like that at all. Use Colorama zones. That's going to get a little chaotic. So like I was saying, you can use this to do a lot of video feedback stuff, but it like digital buffer-based feedback and camera-based feedback, while they have like the same shape of things and you can do a lot of the same stuff in them, they're very different in how they actually operate, because the camera feedback is actually using light to do things, whereas the buffer feedback is just sort of like changing the values. But I think a bit more dynamic things to do is just say, let me grab something oscillating. Let me grab a noise source, and then diff. Make sure I have the right number of period. There we go. So just grabbing one of those simple modulators and then doing the camera feedback off of that. This is where it gets really nice. And then I'm just going to do this for a couple of minutes. If you have any more questions, let me know. If you want to stop by on Wednesday, same time and same channel, I will be doing some stuff on vSynth. Yeah, thank you. I don't know, is this like even remotely useful to anyone? It's kind of hard to tell. Because when you're just on this side of the equation, it just sort of feels like you're just like basically like talking into like an empty room. Okay, so this is helpful. Okay, and then I'm gonna like, I'll keep this up on the Twitch for a week and then probably move this over to like my Vimeo or YouTube or whatever. So if y'all want to like double check on what's happening here, you can go back and read the things. And then I'm also kind of working on a little bit of a thing on my website where I'm going to have like embedded hydra sketches that are sort of showing how to like explore video feedback. So yeah, I guess those will probably be like up for playing with in like a couple weeks or so. But yeah, I should also, I guess, let me know if I should try to do this kind of thing more regularly, because it's, I don't know, it's pretty fun to have an excuse to play with Hydra. And yeah, I'm sure I can always figure out more stuff to ramble about. But yeah, I think that is about it for me, because my throat is sore. Alright everybody, thanks a bunch. Donate if you can, it's always very helpful. And yeah, stop back for vSynth this Wednesday, 8 p.m. EDT, and the Wednesday after that, Video Waves. Same channel, same thing. Yeah, thanks for stopping by. Alright, bye.